grid, or as we used to call them, a Cartesian plane. We don't say that anymore because poor René Descartes, there is an argument that the coordinate grid was in use in other places in the world, and René Descartes did not actually invent it. So we don't call it the Cartesian plane anymore. But René Descartes still gets credit for I think, therefore I am. Which, oh, good gravy. Which all of you should know. Coordinate grid. Now, take your pen or your pencil, even though some of you will be using pen, even though I say do all your math in pencil. And somewhere on this grid, I don't care where, draw a no, I lie. Draw any kind of line that touches, make it a diagonal line, that touches both the y-axis and the x-axis. Any diagonal line. I am not showing you where to put it because I have a reason for this. Every single one of you draw a diagonal line that touches both of these. This is not a complicated request. Please do so. All you have to do right now is draw a line, ladies and gentlemen. This should not take too long. Nor does it require conversation. Just draw the damn line. Okay. There is my line. Now, the chances of my line being exactly the same as yours are infinitesimal. That's a big word that means it's really unlikely. Okay? But what every single one of the 31 lines, I lie, one person is missing, of the 30 lines that we have just drawn do share something. What do they share? They share that point, and they share that point. That point is an x-intercept. That point, because it is a point on the coordinate grid, has coordinates. Those coordinates are what? An ordered pair. What is the x value of that ordered pair? Do any of you know? No. Why don't you know? Because there is no scale. But you do know that it's got an x value. So what do I write in math when it's a value which we do not know? A variable. What would be the only sensible variable to write here? X, because it is an x value. What is its y coordinate? 0. Now, there are 30 lines that we have just drawn in this class. Every single one of them has an x-intercept of x0. So what does that mean for every single x-intercept in the universe? It has the coordinates of what? X, 0. Every single x-intercept. What if I had a curvy line that went like this? Don't draw this one. How many x-intercepts does it have? 4. What are all of their coordinates? X, 0. Everybody understand? In the 10th grade, we will only be dealing with lines. Therefore, there are how many x-intercepts? A maximum of 1 and a minimum of 0, because I could draw a line like that, couldn't I? All right. Using the intelligence that has been granted to you, what is this point? The y-intercept. And using the intelligence that has been granted to you, what are its coordinates? 0, y. How many y-intercepts share that coordinate in all the universe? Every single one of them. Do I make myself clear? That, ladies and gentlemen, is about the most complicated concept in this whole unit. And yet people have trouble with this unit. Everything in this unit is an X or it is a Y. Do you all understand what I am saying? Spectacular. An x-intercept, we already know what it is. Let's explain it. An x-intercept is when a graphed line crosses the x-axis. Coordinates are always what? X0. When? Always. Why? Because it has an X value of which we do not know, but every single dot on this line has a Y value of 0. Do you all understand that? Spectacular. Obviously, then a y-intercept is when a graphed line crosses the y-axis. Coordinates are always what? Y. Why are they 0y? X comes first, and every single dot on this line has an x coordinate of 0, and the y could be anything. Do we all understand this? Spectacular. Now, determine the x and y intercepts for this function and then graph it. Well, that's a function. We still have an x. What is the y? It's the f of x, right? So, I have the x and y intercepts. What is every single x-intercept? x0. What is every single y-intercept? 0y. Now, that is an x value, yes? What is that? An x value. Do I know the x? So can I change that? No. So I have 2x plus 3. What does 2x plus 3 equal? It equals the f of x, which is the y value, yes? Do I know my y value? What is it? So what do I write here? What is my job whenever I have a single variable and an equal sign? Isolate it. Get going. What does x equal? Negative 3 halves, yes? X equals negative 3 halves. What letter is that? What does x equal? Negative 3 halves. So what then is the x-intercept? Negative 3 halves, comma, 0. I do not want to put that on the graph right now. Why? Why is it a bad idea to put this on the graph right now? What about this set of coordinates bothers you? It's a fraction. It's tough to find 1.5 because it's somewhere between those two, isn't it? Can you set it exactly? No, you're not able to set it exactly. So I'll show you what to do in a moment. What is the y-intercept? Do you know the x value? So what do I write instead of x? 0. Do I know the y value? No. So what do I write instead of f of x? Not f of 0. You write y, because this is my output, equals 2 times 0 plus 3. Now you could have written f of 0. What is 2 times 0? Plus 3. So y equals 3. What letter is that? What does y equal? So what is my y-intercept? 0, 3. Now I can think about graphing. Now, this half bothers me, yes? Who is in charge of this graph? You are. Is there any law that says 1 square has to equal the number 1? No. Who decides how big each square is? You do. So if I make each square a half, then it's real easy to find negative 3 halves, isn't it? Negative 1 half, negative 2 half, negative 3 halves. Now, how do you show me that you have changed the scale? You write it down. You don't put a 1 there, you put a 1 there. Now, I know that halfway between 0 and 1 is 1 half. So I know that each square is worth what? 1 half. Everybody understand? Now, in a perfect world, we would keep the same scale on the y-axis. We got to get up to 3, yeah? So let's see if that scale will work. 1, 1.5, 2, 2.5, 3. Does it work? So I can go ahead and keep that scale. What if my y's went off the graph? I would have to change the y scale. How would you show me that? By writing what the y's are worth. Does everyone understand? Later on, we are going to do a question where that happens. And you're going to have to make some mathematical decisions. But we're going to wait on that until it happens. Everybody cool? Now, is this the way we would graph that? No, why not? Oh, Manroop, I stopped you because I was in the middle of a thing. What was your question?
So the y and x can have different...
Yes, the y and the x-axis can have different scales. And let me give you an example of that. If we were doing like population of the world, yes, we've only had, reliable population data in the world for like the last, 100 years maybe? So, but there's 7 billion people in the world right now, right? So I can't have billions and billions of numbers on the x-axis and billions on the y-axis, right? So we have, 100 years taking up this much space, but then up is in the billions. So you understand what I'm saying? It ends up going like this, right? Because we got to get up to 1 billion. We're not going to go up 1 billion squares. Cool? Okay. That was a good question, by the way. Thank you. Where was I, though? I sidetracked myself. Oh, right. Is this done? No, of course not. Why? Because it goes forever, yeah? It's just a function. The domain and the range are infinite. So it would go like this. Yeah, all you need to do is go a little bit past and put the arrows in. Everybody good? Now, obviously, I've just given away the answer to number 2. What is the domain? X is a set of real numbers. And what is the range? Y is the set of real numbers. Because you're going to hit every single number in the universe on both. Everybody good? All right. Let's make it slightly more difficult. Here's your new function. How should we rewrite it if we're going to put it on a graph? How should I rewrite this? I should make this a y. And then I can go ahead because I'm supposed to use the intercepts, yes? So the first intercept is x0. The second intercept is 0y. And I go to town. Go. Can everybody find intercepts? Please notice it's exactly like the function notation that we did at the end of the last unit algebraically, right? We're just substituting. Every single number in this unit is what? An x or a y. Every single function in this unit has what? An x or a y. Is everybody good? You can all find intercepts? Okay. Slope intercept form. Some of you will have seen this, some of you may not have. What do you see in here that you already understand based on what we just did? You see y's and x's. Y's and x's are what? Coordinates. Yes? Every y and x put together is a coordinate, right? They're an input, they're an output, we're cool, yeah? M and B are new things. M is the letter that we use to describe slope. We know slope from the previous unit as rate of change. Now, it was a rate of change in the previous unit because we were always comparing two things, yes? It was the change in the dependent variable divided by the change in the independent variable, correct? But in this unit, we aren't comparing two things. We're comparing two concepts, aren't we? We're comparing x's and y's. So it's no longer the change in the dependent variable over the change in the independent variable. It is the change in which letter? Which letter is the dependent variable? Y. Divided by the change in the independent variable, which is x. So the slope now is delta, which when you take physics, you will learn that triangle is shorthand for change in. Change in y over the change in x. Now on a graph, how do we graph y's? Vertically or horizontally? Vertically. So it is the rise divided by the run. Rise being up and down, and run being left to right. Everybody cool? All right, that's what M is. B is the y-intercept. What? How can that be the y-intercept? What is every single y-intercept? 0y, correct? Look back at the two previous things we graphed. Does this look like y equals mx plus b? Y is isolated, there's a number with x, and there's a constant, yes? When x is 0, what happens to this monomial? It drops out, leaving you with what? 3. What was our y-intercept? 3. When this is, does this look like y equals mx plus b? Y is isolated. I've got a constant. I've got a number with x. When this is 0, what happens? It drops out. What's my y-intercept? -2. Everybody cool? So b is the y-intercept, 0y, because the mx drops out when x equals 0. Does everybody understand that equation? Okay, now we're going to do something also slightly different. Pretend this is on a graph. I'm not going to put the coordinates there because it could be way over here. It could be right in the middle. It's not important. Everybody cool? So we visualize that this is on a graph, yes? Point A to point B. What is that slope? Well, we've already talked about slope. It's the change in y divided by the change in x, correct? So if I'm going from A to B, and I'm on an Etch-a-Sketch where it's impossible to draw a diagonal line, you all know what an Etch-a-Sketch is, right? Okay. I can draw Canada with borders on an Etch-a-Sketch. True story. I don't really get along. Well, that's not true. Going to visit my family at Christmas time can be a stressful time for me. So one year, I just sat there and played with the Etch-a-Sketch until I drew Canada. Including some of the major Arctic islands, I might add. I know, right? Anyway, on an Etch-a-Sketch, because the only thing you can reliably draw on an Etch-a-Sketch is stairs, how would I get from A to B? I would have to draw a stair up and over, correct? Now, when I go up on a graph and I am rising, is it a positive or a negative change? It is positive. When I go right on a graph, what is it? Positive. So if I take my positive rise, which was positive, and I divide it by my run, which was also positive, I end up with what kind of number? A positive number. So this is a positive slope. Now, some kid says, okay, Mr. Mars, what if I went from B to A? All right, kid, let's go from B to A. I did a rise that went downwards. So what is that? Negative. And then I had a run that went left. So what is that? Negative. So I had a rise, which was negative, divided by a run, which was negative, to give me what kind of answer? Positive. Then I say, what do you think of that, kid? And kid goes, because kid was only trying to make me, you know. So, knowing what you know now, what is happening here? If I go, oh, if I go there, what's that? And then I go there, what's that? Negative. So it's a positive divided by a negative, which will get me a negative number. Yeah, but Mr. Mars, what if I go the other way? Let's check, kid. What's that? Negative divided by what's that? Positive. To get what? Negative rise divided by a positive run will still get me a negative slope. Yeah? Yeah. Okay. What's weird about the other two? There is only one. This only has a rise, yes? So it would be a rise. It would be, I want to use a color I haven't used yet. It would be a rise, which is positive or negative, right, kid? Divided by what run? 0. Can you divide by 0? No. That is infinity. It is an undefined number. It cannot exist. And that makes sense, because if this were indeed a slope and I was a skier, would I ski down that? No. I would fall down that to my death. You cannot ski down a vertical slope because it is not a slope. It is a cliff. Everybody understand? Now, you are intelligent young people. What is this guy? What's its rise? Rise is 0 divided by a run of what? Who cares? It's there. Can I divide 0 by other things? Yes, I can. How many pizzas do I have in front of me? 0. I would like to give you all 1/30th of my pizza. How much pizza will you have in front of you? 0. Therefore, it is okay, yes? And this also makes sense because Skier Myers is now a snowboarder on a flat section. Snowboarders look very cool on slopes. Snowboarders look like big old idiots when it's flat because they're hopping along like bunnies. Boinga, 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 boinga. And then their idiot buddy says, yo, brah. And you look away and you go boinga, boinga, boinga on your face. As has happened to all of you if you have tried to snowboard. Now, I do both because I am equally cool. Now, some of you are good on your snowboards and you do that nose to heel running thing, which is again wicked awesome until 1 second you look away and then not only do you fall on your face, you all fall on your face at a high speed, which then all of us skiers who never fall down look at you and go, ha ha! Also, when we go flying past you on the slopes because we can skate and use our poles, we go, ha ha! Especially when you snowboarders get lost and go down the wrong one that's the easiest way down that always has flat sections. What? Your ski doesn't go down the hill because it's got ski brakes on it. When your boot comes out, 2 big poles come down off the bottom of your ski to keep your ski near you. You don't ski on a rink. Your ski does not... Okay, guys. Okay. Yes, they are pretty icy. I agree with you. Now, of course, if you're really smart, in your backpack kit, and you're a snowboarder, you carry a collapsible hiking pole. So you can reach back and get it like the sword of He-Man, go, whoom, have it go, shroom, and then just push yourself along. But then all the other snowboarders are like, look at that loser. And you're like, you're on your face because you're hopping like an idiot. And they're like, F you. Like, okay. I'll see you at the chairlift in 20 minutes when you hop over there. And I'm halfway up the hill. Not that I have anything against snowboarders.
Couldn't you just clip out 1 foot and like...
Oh, that's the other move. You clip out 1 foot and then you do that awkward skateboardy thing where you have to decide, do I put my foot in front of the board or do I do the behind the board thing? And then they still look like idiots. The only time a snowboarder doesn't look like an idiot is when they're actually going down the hill. Which is almost never, because snowboarders also sit in packs at the top of the hill and like, you go, no, you go, no, you go, no, you go, no, you, brah, I don't want to go, you, brah, I don't, you, brah. And then they all go together like maniacs with no respect for anything on the hill. They just go. I love snowboarding. Slope is, what are all its choices? It is rise over run. It is change in dV over change in IV. It is change in Y over change in X. Slope can be positive. Slope can be negative. Slope can be undefined. Slope can be 0. Now, how many times in the last couple of moments, pre the snowboarding discussion, did I say the word slope? A lot. How many different iterations of slope are there? A lot. How important is slope to this graphing unit? Very. Turn the page over. Please, ladies and gentlemen, I am going to graph these 4 lines in 4 different colors. If you have different colors, I would recommend you maybe do that too, but if you don't, no big deal. Just make sure you label them. Are all of these in this form? Yes, they are, which means I have a y-intercept and a slope, yes? Let us start with the first one, cabbages. What is the y-intercept? -4. Where, Ken, do you find the point 0, -4? You find the point 0, -4 on the x-axis? The y-axis. 1, 2, 3, 4. Now, is that a line? No, that's a point. To make a line, I need at least how many points? 2. Better to have 3, right? Because I want to make sure it continues in a straight line, yes? How do I know where to go from here? The slope tells me. My slope is 2. But what is 2 really? How should we really write 2? That we would write it that way if we weren't lazy. 2 over 1. So I have my rise and run, don't I? How do I rise 2 from here? I go up 1, 2. How do I run 1? To the right. And then I go down 2 and left 1. And that makes my line. Is everybody cool? Because, as we just drew, and you all told me you understood, if I go down and left, I keep the same slope. Now, let's do B. Is this in the right form? Yes or no? To quote the BFG. Yes. From the lovely book by Roald Dahl. Is this in the same form? What is my starting point? 0, 1. What is my slope? -1. So I must go where? Down 1 and right 1. Or up 1 and left. Could I go up 7 and left 7? Could I go down 73 and right 73? Yes. Does everyone understand? And I would draw my line with my little arrows. Yeah? What about C? Where do I start? On which axis, Jordan? the y-axis. 1, 2, 3, 4, 5. And then how do I draw it? Slope is rise over run, which also equals m, and in this case, m is 1/3. So, how do I make a 1/3 slope that is negative? I go down 1 and right 3, or up 1 and left 3. Brilliant! And finally, how do I do D? Tricky. What's the y-intercept? Oh, there's a y-intercept, all right. It's 0. And what's the slope? 1. Positive or negative? So I go up 1, right 1, or down 1, left 1, or up 7, right 7, or down 73, left 73. Correct? Is everybody good? Now, quick reminder from last unit. What color line will I find the f of 2 on? Which color? The blue one, right? F of 2. 2 is an x value, yes? There is x equals 2. What's the y value? 0. The f of 2 equals 0 because we're getting it from the graph. Where will I find the h of 3? What color line is the h of 3? Which? Green. H of 3 is an x value, yes? So I go out 1, 2, 3. I go up. Oh, there's my h of 3. What's the y value? 4. Brilliant. Where will I find the g of x equaling 4? What color line? The reddy pinky one, yes? G of 4. Where is the g of 4? Oh, it's not the g of 4. Where is the g of x 4? On the y-axis. 1, 2, 3, 4. So somewhere up here, yes? But I haven't drawn my line to there. But I know my line is going to go up and left, up and left. There is my 4, yes? Or is that 5? Right, there is my 4, yes? So what is my x value? -3. And f of x is -1. Which color line am I using? Which one? The blue one. So I go to, was it -1? I'm sorry. F of x is -1. So I go to -1 and I go out and I go up. What's that? No. 2 is right there. Is it 1? It's 1.5. Everybody good? Everyone can deal with slopes? Yeah, 100%? All right. You're going to work on page 226 and page 227. This page uses intercepts. Again, I remind you, every intercept is either x0 or 0y. This page uses slope-intercept form. Y equals mx plus b. M is rise over run, and b is the y-intercept. Yeah? Yeah. 34 minutes to work on that. Now,